Hey guys, I hope you all are doing good. In this lecture, we will be starting with Boolean algebra, right? So this is basically just based on zeros and ones, and we will understand how the logic works and a lot of other things, right? Before I start, I just want to explain why are we understanding this in the first place, right? So the basic point is, I think we all know from our high school that computers basically understand just two letters, right? Which is zero or one. So a computer can only understand either zero or one. But what exactly do we mean by a zero or one, right? Like how exactly does this work? So the basic idea is, right, that any wire has some voltage flowing through it, right? It can either be 0 volts or it can be some value more than that, right? Let's say 4 volts or maybe something 5 volts. So what we assume is that when there's no voltage, we assume it that it's zero value. And if there's some voltage flowing through it, we assume it as one, right? So this is the basic idea. And what we usually did is, right, computers don't, they just basically understand that there's either zero voltage or 5 voltage flowing through it. And we base the entire computer operations around it, right? So based on the zero and one values, we understood or we made logic so that we can make the computer understand any concepts, right? So we can make computer do some work for us and a lot of other things, right? So I think over the last maybe 100 years, we have progressed so much on it, and now computers can do so much more than just basic math. So that's basically it. But this is just a basic. In this section, I'll just give you a basic idea of how that logic is made and how we basically do it, right? And how computers understand it. So let's start with what is Boolean variable and what are values, right? So um, basically, in Boolean algebra, variable can take two values, 0 or 1. Just like I said, right, there's only two values possible. Either it can be a value 0, which basically corresponds to 0 volt flowing through the circuit, or it could be 1, which basically means 5 voltage or some kind of a voltage flowing through it, right? So that's basically it. Now we need to understand that how do I, have some kind of a problem and I convert it into some kind of an expression that the computer can understand, right? Basically convert it into some kind of zero and one value type of thing. So for that, we have basic Boolean operations. Let's start with understanding the first one, which is the not operation, right? If you've watched my propositional logic videos, then you will probably know how all this works, but I'll still give an explanation in this lecture, right? If you have covered propositional logic and if you understood it in detail, then Boolean algebra should be pretty easy to understand. So um, but even if you've not covered it, that's also totally fine. I'll still explain every single concept in detail, right? So let's first try to understand what is the not operation, right? Not basically just converts 0 to 1 or 1 to the 0 value, right? And we just denote it with this negation sign and symbols. So if the value of a variable a is 0, right, negation of it would be 1. And if the value of it is 1, negation of it would be 0, right? So I hope that's very easy to understand. In one of the next lectures, we will also be covering logic gates. So, but for now, just try to understand each of these Boolean operations, right? Okay. Second one is the AND. So let's try to understand how the AND works, right? This is basically a dot product, right? Or I should say just a basic multiplication of A and B. So if you think about it, right, 1 multiplied by 0 gives a 0 value, right? 0 multiplied by 1 gives 0. 1 multiplied by 1 gives a 1, and 0 multiplied by 0 gives a 0 value, right? This is just a basic idea of if you get confused on how the AND works in Boolean algebra, then you can just think of it like it is basically multiplication of the two variables, right? So but the basic concept or the logic behind it is that when it comes to AND, right, when I'm talking about AND, I basically want both the values to be true in order for the solution to be true, right? In order for the answer to be true. So if you think about it, over here, one value is true, the second value is false, which corresponds to false, right? I want both of them to be true in order for the final value to be true, right? So if you look at it, when both the values are true, only in that case, the final value, which is a dot b, is going to be true. In all other cases, it's actually false. Now, in OR, it is basically the opposite of it, right? In OR, in every single case, except when both the values are false, right, other values are going to be true, right? So in OR, I just want one of the values to be true, or I should say one, right? And I don't care about any other value in that case, right? So if you think about it, even if you try to add the values, right, 1 plus 0 is 1, 0 plus 1 is 1, and in Boolean algebra, it's very important to understand that 1 plus 1 is also considered to be 1, right? So if you get confused, don't write this as 2 over here. This is actually going to be 1 in the case of Boolean algebra, right? So I hope you were able to understand all the Boolean operations and just a basic idea about why are we studying the Boolean operations in the first place. Okay, moving on. Let's try to understand some of the properties for Boolean operations. Now, these properties are going to be important so that we can basically simplify Boolean operations in the future, right? Okay, so move on. Let's move on to different properties. Okay, so I've given all these Boolean identities on the board, right? Starting with identity laws, domination laws, and all these laws, right? I think these three laws should be very easy to understand, right? But for all the other laws, if you have any doubts, I would highly suggest that you watch one of my previous videos where I've explained all these laws in detail, right? The only difference is that there's like a different notation in this case, and that's basically it, right? So I'll give the link for that video in the description. But if you already understand it, then I would like you guys to just pause this video and then just try to understand and recap all these laws once again. And then we will solve a few basic examples or simplifications based on these laws, right? So you can pause this video and just note these down. Okay, so I hope you have noted down all these laws. Now let's just solve two basic examples, and then I'll be giving a bunch of practice questions for you guys to solve, right? Okay, so let's say I'm supposed to simplify this expression, right? Simplify a plus a dot b, right? This is the expression that I've been given. Now, basically, this can just be written as a, right? This is actually called the absorption law, but I'm going to give you a basic way of using the laws that we covered just right before this, right? So take a look at what I'm doing, right? Whenever you're going to simplify any expressions, just try to find some ways you can find you can use the laws, right? So what I'm trying to do is I have all these laws in my mind, and what I'm trying to do is that I'm trying to find some way to make any manipulations in the equation so that I can use those laws. So right now, I don't see any way. I see some way I can use it, right? What I'm trying to think is maybe I can use the distributive law in this case, but how am I supposed to use it, right? First thing I do is I can write a dot 1. I can write a is equal to a dot 1. Think about it, right? This is the identity law. I know that if I do dot with a, right, 1 with a, then it basically results in a over here. So I can write this as a dot 1 plus a dot b. Now I can apply the distributive law, which gives me a dot b plus 1. And think about it, right? If I do b plus 1, right, b can only take one of two values. It can either be 0 or it could be 1. Either case, since we are adding a 1 to it, or if we are doing the AND with a 1, it should result in a 1. So this is going to be a dot 1 in this case, and this finally results in a, right? So my exercise for you guys would be to write down all the laws over here of whatever I've used, right? Let's take a look at another example. Let's say I have 1 and let's say 2, right? So a plus b dot a plus negation of b. Now, maybe the examples that I'm doing are pretty easy to solve, right? But usually, just like I would suggest that the more practice you have, the more questions you solve, and the better understanding of the laws you have, the easier it is going to solve these questions, right? So now let's take a look at this example, right? Now, it might seem like how am I able to solve these questions, in such a easy way? And my only answer to that is it's a lot of practice behind it, right? So I've solved a lot of questions, I have solved a lot of equations, right? And that's the only way that I've been able to understand how exactly which law am I supposed to use, right? So looking at this equation, right, when I'm trying to figure out what law can I use, I find out, or I see that I can maybe use the distributive law again, right, which is a plus b dot a plus negation of b. So this basically means that this is a plus b dot negation of b. What is b dot negation of b, right? This is going to be 1 dot 0, which is going to be 1, sorry, which is going to be 0. So this is gives me a plus 0, which results in a in this case, right? So I hope you were able to understand how we simplify equations, right? Once again, understand the logic, all the laws in detail, right? Solve as much questions as you can, right? Trying to use each and every single law possible. And I think that would give you a basic and general idea about how you can solve these questions, right? Now, I'll be giving a bunch of questions for you guys to solve to simplify equations. And the next lecture, you'll try to understand how or why are we, understanding how to simplify these equations in the first place. Okay, so I've given these 4 questions on the board. I hope you were able to understand how to draw the truth table by now. Right? You're basically just supposed to take the values of A and B and the final equation. So basically kind of like A, B, the equation, which is negation of A plus B, and write it down for every single possible combination, right? So maybe it could be 1, 1, 1, 0, or 0, 1, etc., right? So first thing is draw the truth table for this. This will just give you a basic general idea about how this works, right? Second and third are simplify operations. And in the third one, what you're supposed to do is basically what you can do is either you can simplify both these equations, or maybe you can draw the truth table for each one and compare those truth tables, right? And if you see the truth tables are not equal to each other, then that means they're not equivalent, and otherwise they are equivalent, right? Okay. Lastly, for the third question, remember that over here, just giving a hint, you can use the De Morgan's law, right? So that's it for this lecture, and I'll see you guys in the next video.